Hi, thanks for joining me today. Would you mind introducing yourself?
Hi, Nusha. My name is Jason Smerdon. I'm a professor of climate at the Columbia Climate School.
Great. So, can you talk about your work and what you do at Columbia Climate School?
Well, I wear a lot of different hats. One of them is in the climate research space. So I study the climate of the last several thousand years, how climate has changed and varied over that time scale. And then I try to use that information to understand how the climate is changing presently and what's in store over the next several hundred years using climate models and other things. And one of the specific research areas that I work on is droughts, looking at droughts globally, but most specifically in the American Southwest, what drought variability has looked like in that region and what it tells us about the current mega drought in the Southwest that's been going on now for over 20 years, and how the aridity trends in that region will change over time.
Yeah, definitely. So, can you talk about kind of some specific projects that you might be doing in regards to like the droughts?
Yeah, so one of the things that we're really interested in right now is how vegetation it plays a role in drought dynamics. So you can think about vegetation on two sides of the same coin. One, drought is obviously not good for vegetation, and it has its impacts on vegetation. But on the flip side, climate also is modulated through vegetation. So for instance, soil moisture is influenced by how much moisture plants take up and release back into the atmosphere. And plants are going to respond in the future to two different things. One, the changing climate, but also the increasing CO2. So increasing CO2 is actually beneficial for plants. It means that they can use water more efficiently by using less water to take up the same amount of carbon from the atmosphere as the amount of carbon in the atmosphere increases. So that efficiency allows them to use less water to photosynthesize. And so there's one side of thought that because plants can be more water use efficient, they won't take up as much soil moisture and they will mitigate the amount of drying that we experience in the soil. The other side of the coin, though, is how plants respond to climate change, and through longer growing seasons and through the fact that they'll put out more leaves, they may actually use more water. And so we're both trying to understand how that process actually works in the real world and how those processes are modeled in climate models, and then what kind of modeling decisions in the climate models mean for how soil moisture and vegetation is modeled in the future under changing climate conditions, as well as increasing CO2 conditions. So that's one thing that we're doing and I'm excited about. The other one that I'll tell you about quickly is we're really interested in how climate will respond to volcanism. So volcanoes impact climate, and they have in the past, and they will continue to do so in the future. And people have a lot of understanding about how volcanism cools the climate for a couple years after very large eruptions that happen in particular in the tropical regions. But it's less understood how the water cycle will respond to the volcanism. And so we're really interested in looking at how what we call hydroclimate, basically parts of the water cycle, will respond and change things like soil moisture at the surface. And what we're finding is that these events can actually have impacts on hydroclimate for longer than a couple years, which we think is through a mechanism in the ocean as the oceans change in response to large volcanism. And so this is actually a problem independent of climate change, but moving forward as the climate changes, we're also interested in thinking about how these volcanic impacts will change in a warmer climate as well.
Okay, great. Yeah, I think the work you're doing is definitely really important. So, can you talk kind of about what led you to Columbia Climate School, like maybe what you did in college and kind of the career path that you took?
So equal parts luck and circumstance and interests. So I started out in physics. That's what I did as an undergraduate major. I took some geology class and was actually thinking about double majoring in geology. And for one reason or the other, I had some experiences in some geology classes that I wasn't super geeked about. And so kind of focused on physics predominantly in my undergrad. I went on to graduate school in an applied physics program and was doing biophysics when I first got to the University of Michigan. And it largely involves shooting proteins with lasers and looking at what's called protein kinetics, how the proteins fold and evolve under different stimuli. It sounds cool, but and it was cool on some level, but it actually wasn't connected to the kind of big picture problem that I was interested in, or I didn't see as much of a big picture connection. And the other thing that was going on is I was involved in a lot of environmental activism and a few different political campaigns. And I always thought that that could kind of exist in this, independent of what I was doing professionally. And I decided at this point in graduate school that I really had to put the two together. So that's a very shorthand description of, a lot of sort of existential searching. Everybody goes through this, and this is one of the things I try to explain to my undergrads. There are all kinds of different things that happen to you over the course of your career path that force you to reckon with what feels right, what your values are. And this was certainly a big moment for me in my life. And so I was very lucky to start working with somebody who was he was a geophysicist, Henry Pollack at the University of Michigan, and um, he was working on a project that was geophysics in nature, but it was connected to paleoclimate. And
Hmm.
so I took a class called The Science and Politics of Global Warming from him and his wife. His wife was president of the Michigan Environmental Council at the time. This is late 90s, so global warming was definitely out there as a subject, but it was not as ubiquitous as it is now. And they were teaching this class where he was teaching the science and she was teaching the politics. And it was kind of love at first sight. I realized that I saw a path that I didn't know existed before. It turned out that Henry was in the market for a student, so I was able to with him. And I would say there's also a lesson in terms of the interdisciplinary nature of what I found. So I came out of a small liberal arts school that was, it was a great education, but the traditional disciplines were most strongly represented. And I had no idea. Well, I thought that geophysics was just seismology. And I didn't know that somebody with my kind of training could go into climate and what that meant. And so this really opened my eyes going to a large university where a lot of the disciplines are overlapping and very interdisciplinary in nature. And this was a geophysics application that was novel and new and really being driven at the cutting edge of research at the time. And the rest is history. I got excited about climate, in this case, paleoclimate, before coming to Columbia as a postdoc and then staying on to the point where I am now.
Yeah, I think that's really amazing. I think a lot of people end up where they are, especially in academia, because of like a professor, like a research mentor, like kind of what you experienced. So I think that's really cool. So you talked about how you were a physics major in undergrad. So then I'm assuming you didn't do that much stuff with regards to climate change in high school.
I didn't. We had, ninth grade earth science at the time, and I guarantee you that if climate was represented, it was a very small portion. So we probably, I think that the traditional way of teaching it is a lot of earth history, some planetary science, but climate, I don't think was, I certainly don't remember climate as a subject that I was introduced to almost until grad school, really.
Okay. So what were some challenges that you remember facing in terms of like pursuing the like climate field?
Well, one is as I was describing, I don't know that this is the same now as it was when I was going through, but climate was it was certainly a discipline that was practiced in a lot of spaces, but I think I wasn't as aware of it, and part of that's just my own ignorance, but part of it was this emerging discipline, and so finding it and figuring out where someone with my training fit was something that I definitely had to work out. Um, and part of the challenge there was, transitioning from one field, which was physics, and very specifically what I was doing in physics, to this very different discipline, and just having both, I guess, the faith and the audacity to change and move into something I knew very little bit about. I felt comfortable with the physical elements and the mathematical elements, but a lot of the specific domain knowledge was something that I had to learn on the fly. There's also a lot of statistics in climate, and something that I've learned a lot along the way, but that was also something that I had to learn through my research. And I think the truth, if we're talking very specifically about doing research, one of the biggest challenges of becoming a researcher and moving into a research field is just accepting that you're stupid and you don't know anything, right? I mean, research at its very core is sort of diving in to the unknown where no one knows the answer, and sort of recognizing that that's the process. It's a feature, not a bug of the process, where you're not supposed to know it all. And in some ways that was hard, but in some ways I was also aided by the fact that I was coming from another field, because I could ask the dumb questions because no one expected me to know them. And I was free, to ask whatever I didn't understand. And it's a lesson for all of us, quite frankly, is we should all be able to ask the dumb questions, if you want to phrase it like that. And no matter what you think you're supposed to know in a class, you shouldn't be afraid of saying, I don't understand that. I don't get your logic. And you shouldn't limit yourself by assuming you're supposed to know it.
Yeah, no, I definitely think that's really important. I think a lot of times people like hide the fact that they're confused or like that they don't understand something that might seem like trivial, so to say. So yeah, I think it's really important to be asking those questions, especially when you don't understand. So it seems like to kind of overcome like the challenges of climate being more of like an interdisciplinary field, you kind of just like self-taught yourself and went about learning it kind of on your own outside of a classroom setting.
There was a lot of that through the research that I've done. I also have the benefit of, now being at Columbia, where there's a huge, at Lamont Doherty Earth Observatory and now the Climate School, there's a huge critical mass of people working across the climate spectrum. I'm speaking first and foremost, when I came to Lamont, there I really learned climate in depth by virtue of the fact that I had this huge collection of experts in the field to talk to. So talking to people, engaging people about their research, going to seminars, a lot of that was the process by which I learned what I needed to learn. And now, we're kind of going through another process where, climate as a subject and a discipline, certainly the way that we're casting it here at the climate school, is one that includes traditional natural science perspectives, but social science, humanities. It really is this massively interdisciplinary field. When I was talking about interdisciplinary before, I was really talking about, the sciences. But now I get to talk to people who are historians, who are lawyers, who are anthropologists, and that ability to just continue to learn and evolve and think about how these pieces all fit together is something that requires a humility, an ability to communicate across a lot of different boundaries, translate, synthesize, all of these things that are critical for being able to learn in a very interdisciplinary, even transdisciplinary space.
Yeah, definitely. I think that one thing that's definitely important is not only learning like facts and content and stuff, but it's also just like learning how to learn, like learning the soft skills and things like that, which you talked about. So I think that's really great. So this has been a really helpful interview. So just kind of to wrap up, what would be some advice that you might offer to high school students who are looking to pursue the climate field but aren't necessarily able to like in a classroom setting because it's not really taught in school?
Well, there's a lot that you can do to educate yourself. So, there's no lack of information out there, from, very approachable books to online content. And then don't forget about your communities. There's a lot of information in your communities, a lot of organizations, a lot of groups that are working on this from a lot of different angles. And, getting engaged with those groups is a critical way to understand a couple of things. One, understand the problem and what is important to you about that problem, but also learning about the very local impacts of climate change. I think a critical part of this discussion is not just the global picture, but how these things are going to translate to impacts on the ground in our communities. So I think that's a critical process from multiple angles. The other thing I would say is that The nature of the climate challenge is that it requires a huge number of tools to address it. And so what I would encourage high school students to think about is what they're passionate about and the tools that they have and how to use those tools in the context of the climate challenge. So there's not a perfect way to talk about this. There's not a silver bullet to address this challenge. We need everybody with all of their talents, with all of their different tools. If you love music, think about how to address the climate challenge with music. If you love science, do it with science. If you love activism, think about how to do it as an activist. All of these different elements need to be things that we bring to the table. And so I would say the most important thing for high school students to think about is what is it that they're passionate about and how can they use that passion and interface it with the climate challenge? How is the climate challenge going to impact their area of importance and interest, what they're passionate about, and really put in the time to think about how you can make an impact in that specific area in a way that is going to drive your passion. So this is the other thing. If you're going to sustain yourself in this work, this is not something that's going to be solved in a couple years or in a decade. We're all going to be working on this problem for the rest of our lives. And so if you're going to sustain the work that you're doing on it, you better find it important. You better find it fascinating. You better find it something that really motivates you. And so finding those things and figuring out how you're going to use your tools and talents specifically is probably the most important thing that you can do in addressing the challenge.
Yeah, definitely. I think that's really good advice. And I think it is really important to consider the fact that climate change does touch everything and you can apply almost any field to solving the problem. So I think that's good advice. And yeah, thank you for doing this interview. It's been really great. I think that your kind of like journey has been definitely significant. And I think a lot of high school students might relate to that in terms of like where they're looking to go. So yeah, thanks for taking the time to do the interview today.
You're welcome, Anusha. It was a pleasure.